By definition, acids are substances that dissociate into protons in solution. The higher the concentration of protons in a solution, the higher the solution's acidity is. A weak acid will partially dissociate into protons and ions in solution, forming an equilibrium in the solution, which is mainly reactant favored. Mainly, you're going to have the acid form in the solution. However, you'll have some dissociation, and we can actually form an equilibrium constant with the dissociated form on top with the protons and the actual acid form on the bottom. Strong acids are not like weak acids. They will completely dissociate into protons and ions in solution. And that's why the initial amount of acid added to a solution will end up equaling the amount of protons in the solution. In order to minimize the effects of an acid, bases are proton acceptors, which will take protons and convert them into something else. For example, hydroxide will react with water with the proton to form water. By definition, hydroxide is a base because it's reducing the concentration of protons and decreasing the acidity of the solution.
A buffer is a solution that resists changes in pH when small amounts of acid or base are added to it. Buffers are crucial in maintaining the stability of pH in various chemical and biological systems. A buffer typically consists of a weak acid and its conjugate base, or a weak base and its conjugate acid. The key principle behind how buffers work lies in the ability of the weak acid-base pair to react with added acid or base, thereby minimizing changes in pH. When an acid is added to a buffer solution, the weak base component of the buffer reacts with the added acid, converting it into its conjugate base. Similarly, when a base is added to a buffer solution, the weak acid component of the buffer reacts with the added base, converting it into its conjugate acid. These reactions help to keep the pH of the solution relatively constant.
Before measuring the unknown, you have to calibrate the pH meter. First, you have to rinse it with distilled water. Once it is rinsed with distilled water, you have to go to 2-point calibration and put the probe inside the pH 7 buffer. Once it stabilizes, you type in 7 with the appropriate amount of decimal places. Then you will rinse it again and then place it in the pH buffer of 4. Once the pH meter stabilizes again, you type in 4 and apply it. When measuring the pH of the unknown, make sure to rinse the probe with distilled water after every use. And make sure you record the pH with the appropriate amount of decimal places. The pH of the solution will be the pH that is most constant on the pH meter.